Welcome to Maths for You channel. Past question on remainder theorem. Let A, B are elements of real numbers. Write down the discriminant of the equation 3x squared minus 2a plus b x plus ab equal 0. The quadratic equation in terms of a and b, and hence show that the roots of this equation are real. So the discriminant we need to find and then prove the roots. Two roots is a quadratic equation. Two roots are real roots. Let me write that equation, the given equation again. 3x squared minus 2 times a plus bx plus ab equal 0. Prior to find the discriminant, just to go through the fundamental, the discriminant formula. If the quadratic equation in the form of a squared plus bx plus c equals 0, the discriminant is b squared, the coefficient of x squared, minus 4 times a, the coefficient of x squared, times c, the number itself. So b squared minus 4ac. If we compare this a squared plus b squared plus c to the given equation, a is 3, b is minus 2 times a plus b, c is ab. So the discriminant is b squared minus 4ac. So b squared is minus 2a plus b squared minus 4 times a is 3 times c is ab. So if we could expand it, minus 2 squared is 4, and then a plus b squared is a squared plus 2ab plus b squared minus 4 times 3 is 12ab. Simplified, 4a squared plus 8ab plus 4b squared minus 12ab. From that, we can get the discriminant in the shortest form or simplified form, 4a squared minus 4ab, 8 plus 8b ab minus 12ab, that is minus 4ab plus 4b squared, that is discriminant. Then we need to prove that the roots are real roots. If the quadratic equation, the roots of the quadratic equations are real, the discriminant has to be greater or equal 0. Greater or equal 0. So the discriminant is 4a squared minus 4ab is b squared. So let's see with how we can prove that greater than 0. Instead of writing it as it was, just what I'm doing it, simply 4a squared minus 4ab, no change. Instead of 4b squared, I just split that 4b squared into b squared plus 3b squared for purpose. So if you look at it, 4a squared minus 4ab plus b squared is a complete square. That is 2a minus b. 2a minus b squared is that. So 4a squared, 2 times b, 2ab, another 2ab, 4 minus 2a, 4ab, and b minus b minus b, b squared. So that's complete square plus 3b squared. Because of 2a minus b squared is complete square, that has to be greater or equal 0. And again, 3b squared is a complete square, 3b squared. So that is greater than 0 too. So having got those two functions are greater than 0, the discriminant itself must be greater than 0 as form of those two functions. Therefore, the given equation has real roots. That's done. Right, the next one. Let alpha, beta be these roots. So those are the roots of that equation. Write down alpha plus beta and alpha, beta. So the addition of roots and multiplication of multiple of roots in terms of a and b. Let's do that first. alpha beta roots. So alpha plus beta, it's a standard format with minus b over a. Minus b is minus 2a plus b. So minus and minus 2a plus b divided by a is 3. So minus minus plus 2/3 of a plus b. That is alpha plus beta. Alpha into beta, alpha times beta is again c over a. If it's a normal standard format, c over a. C is ab. B is, sorry, A is 3, so 1/3 of AB. So alpha beta, 1/3 AB. Again, so alpha beta, done. Alpha plus beta and alpha beta, done. So the next one, now let beta equal alpha plus 2. Show that a squared minus ab plus b squared equal 9. We need to prove a squared minus ab plus b squared equal 9. Then deduce that modulus A less than or equal 12 and find B in terms of A. Just deal with that. So beta is alpha plus 2. Right. Yeah, before that, we need to prove a squared minus ab, b squared, right? Okay, that is this one. A squared minus ab plus b squared equal 9. We need to prove that. So in order to prove it, I just took left-hand side to deal with. So a squared minus ab plus b squared. Having got this one, but we have something alpha plus beta in the form of a plus b in terms of a plus b, and alpha beta ab format. So we just try and make it a plus b out of this one, but that's not easy. So we can write the complete square, a plus b squared. So a plus b squared, so we can write a squared plus 2ab plus b squared. But we got minus ab, so therefore minus 3ab. So if you do that, a squared plus 2ab minus 3ab is minus ab plus b squared. So we haven't changed anything, but we rearrange it such a way we can get the complete square of a plus b. So the first part is a plus b, that is, so a plus b squared minus 3ab. So now the left hand side we change it to a plus b and ab format. A plus b, we know alpha, we can change that a plus b in the form of alpha plus beta. Alpha plus beta, we already found 2/3 of a plus b. Therefore, a plus b cross multiplication 3/2 alpha plus beta. The alpha beta 1/3 of ab. Therefore, ab is 3 alpha beta. So just to substitute that, left hand side again, instead of a plus b, that is 3/2 alpha plus beta squared minus 3 times 3 alpha beta, sort of, because of AB's alpha beta. So, yeah, 3 alpha beta, right. So 3/2 squared is 9/4, and alpha, instead of beta, alpha plus beta, minus 9 alpha, then again beta equal alpha plus beta, that is that's what we have been given. Inside the bracket, alpha plus 2. So we can take 2 out. If we take 2 out and square it, is 4. So 9/4 times 4, alpha plus 1 squared minus 9 alpha plus 2. This 4 and this 4, this the denominator 4 and this 4 cancelled out. 4 and 4 cancelled out. So what we have, 9 alpha plus 1 squared. If you expand it, alpha squared plus 2 alpha plus 1 minus 9 alpha squared. If you remove the bracket, 9 alpha times alpha, 9 alpha squared, minus times plus is minus, 9 times 2 is 18 alpha. So if you take the bracket out to from the front of the function, 9 alpha squared plus 2 times 9, 18 alpha plus 9 minus 9 alpha squared minus 18. So 9 alpha squared plus and 9 alpha squared minus cancelled out. 18 alpha plus and 18 alpha minus cancelled out. All we have just 9. That is its right hand side. So we have proven right hand side equal left hand side, which is 9. So that is a squared minus ab plus b squared equal 9. So that's proven. Let's look at the... right. So now we have proven that part. Now deduce that the modulus alpha less than or equal 12. Right. Okay. So if I could take the b as b, well, rearrange it, b squared minus ab plus a squared. I just want to split it to make a complete square on this side, in complete square and b. 3 over 4 a squared. So quarter a squared, and 3/4 a squared equal 9. This b, so b squared minus ab plus a squared over 4 is a complete square. So that is b minus a over 2 squared. And take that 3/4 the other side of the equation. So 9 minus 3 over 4a. But this b minus a over 2 squared is a complete square. That is greater or equal 0. Because of the complete square, it has to be greater or equal 0. If that's so, the equal function on the right hand side, 9 minus 3 over 4a squared, must be the same, the greater equals 0. So 9 minus 3 over 4a squared greater equals 0. So keep that, just to rearrange it. So 9, take that 3 over 4a squared to the other side of the sign, the inequality sign. So 9 greater equal 3 over 4a squared. And just make it the other way around. So 3 over 4a squared, it's 3 over 4a squared is less than or equal 9. So just what I wrote it here. 3 over 4a squared less than or equal 9. Then cross multiplication, 4 times 9 is 36 divided by 3. So a squared less than or equal 36 over 3, which is 12. So a squared less than or equal 12. A is less than or equal plus or minus root 12. But we're talking about modulus A. Just ignore that plus or minus business. So A, the modulus A, less than or equal 12. That is one of the question. We need to prove that again. Again, find B in terms of A. So find B in terms of A. So that's done. So if I could think that the function a squared minus ab plus b squared equal 9, you take the 9 to the other side. So b squared minus ab plus a squared minus 9 equal. So if you think this is the variable b, so b squared, we need to find the value for b squared. We need to find b in a. So b equal minus, is within, if the equation a squared, ax squared plus bx plus c. So minus b. Here minus b is a, minus a. So minus a plus or minus square root of minus a squared, that is a squared, minus 4 times a, the coefficient of b squared is 1, and c, a squared minus 9. That's what. So divided by 2 is 2a is 2. Minus plus a, plus or minus. If we could expand it, this one going to be a squared minus 4a squared plus 36. So I wrote it 36 minus 3a squared. So a plus or minus square root of 36 minus 3a squared divided by 2. Yeah, b in terms of a. That's done. Okay, the next question. B. Let C, and in bracket, not equal 0. C isn't equal 0. And D be real numbers. And let the function of x equal x cubed plus 4x squared plus cx plus d. So the third order or third order polynomial, the remainder when fx is divided by x plus c is minus c cubed. Also, x minus c is a factor of fx. Show that c equal minus 2 and d equal minus 12. Let's deal with that. Right. This is the equation fx equal x cubed plus 4x squared plus cx plus d. The fundamental concept of remainder theorem is this is when you to divide by x plus c, so x equal minus c. So function of minus c is the remainder, so that is minus c cube. So function of minus c equal, so substitute for minus c to x. So minus c cube plus 4 times minus c squared plus c times minus c plus d, that is equal minus c cube, which we have been given. So the minus c cube plus 4c squared minus c squared, because we just removed it, minus c cube, that is minus c cube. Minus c squared is c squared, therefore 4c squared, and c times minus c is minus c squared plus d equal minus c3. If you bring that c3 to the left hand side, that will be plus c cube. So plus c cube minus c cube cancelled out. So what we left with, 4c squared minus c squared, which is 3c squared plus d equals 0. This is equation 1. Next information, next data given, x minus c is a factor. Therefore, again, the remainder, f of c is 0, because if it's a factor, the remainder will be 0. So when x equals c, that is equal 0. So just substitute that. C cubed plus 4c squared plus c times c plus d equals 0. The remainder is 0. So if c cubed, 4c squared and c squared, 5c squared plus d equals 0. That's equation 2. With that equation 1 and 2, we can eliminate d and find c. So 2 minus 1, equation 2 minus 1, c cubed, there is no c cubed in equation 1, therefore just c cubed. 5c squared minus 3c squared is 2c squared, equal d cancel, equals 0. Those of you sort of leaving the line, sort of jumping, to next line. So if anyone wanted to redo it, just do a few more steps for you to understand. So c cubed plus 2c squared, and we can take c squared out, and c plus 2 equals 0. So either c squared equals 0, or c equals 0, or c equal minus 2. But c cannot be 0, because we have been told here c in bracket not equal 0. So c cannot be 0. So c is not 0. Therefore, c equal minus 2. So we proved c equal minus 2. Now it's d. So any one of this equation 1 or 2. So I just took 1. 3c squared plus d equals 0. C squared is 4. C is minus 2. Therefore, c squared is 4. 3 times 4 plus d equals 0. 3 times 4 is 12. You take it to the other side. D equal minus 12. Again, that we have to prove, which we have done. So that's done. So d minus 12. Right. The last part. For these values of c and d, find the remainder when fx is divided by x minus 4. Just remainder when you divide by x minus 4. So the function, we know c and d, so we can substitute that. So once you substitute that, when you divide that function by x squared minus 4 remainder when it's divided by, yeah, x squared minus 4. Yeah, find the remainder. So simply just did a long division. So first of all, write that fx equal x cubed plus 4x squared. Cx is minus 2, c is minus 2, so minus 2x minus 12. That's so if you divide this function, third order function or cubic function, by x squared minus 2, it's a long division. We can work through this remainder theorem, but we don't need to spend more time and confuse ourselves. It's simply they didn't tell us how to do it, so therefore just long division would be a quicker way, I believe. So x minus 4 and long division, so x squared, so x makes it x cubed, x times x squared x cubed, x times minus 4 minus 4x. So I just wrote it under the x functions. So x cubed, so if you do that, x cubed, as you cancel out, the 4x squared will be same, and 4x minus 4x become plus 4x, so minus 4x 2x is plus 2x. So 4x squared plus 2x. Then, so 4 term, the, yeah, 4x squared, yeah, 4x squared, and 4 times minus 4 is minus 16. I just put minus 16. Now 4x squared, 4x squared gone, 2x, and minus 16 will be become plus 16, minus 12 is 4. See, so the remainder when the function divided by x squared minus 4 is 2x plus 4. Thank you. Please subscribe the channel and pass this or share this contents to other friends and your friends and other students. If we have any questions, or if you do need any more clarifications or steps you don't understand, please send me comments and I could sort of go through it or do another video and go through certain steps which you are not understand. Feel free to send me some comments and I'll make videos on them. Thank you.